You doing? Welcome to live stream number 119th. Today is January 12th. It's 2018. My name is Lars Christensen, and thank you so much for taking the time to join today's live stream. It's Friday, man. We made it. Woo! It's good to finally make it here. 5 days of live streams, and today is all about CAM. That is what we do on Fridays. We got Woodcrafts here, we got Tommy here. Absolutely appreciate it. We're gonna jump in. Today's topic is how to machine an STL file. We've talked a little bit about STL files this view. It's not my language. I'm just trying to use it. This week we have talked a lot about STL files, and of course the CAM development team made it available to actually also to be able to machine it. It's Friday. What is awesome. So we're going to get into that. I'm going to show some other tips and tricks along the way. So even if you are not just, STL files or something like, then I think you hopefully will pick something up. You let me know in the comments areas. I'm going to jump in and do this right now. I will just take 1 second. I know that some people is like, stop talking. Thank you. I want to thank all you guys who comes in with the comments and the suggestions for all these live streams. It's really, honestly, it means the world to me. Every thumbs up, even the thumbs down, bad comments, whatever it is. I really appreciate you guys taking the time. So let's jump into this. Enough talking to me. So one thing I did not cover yesterday that I should have covered yesterday when we talked about bringing STL files in was that when you bring an STL file into Fusion, the best way to bring it in is to go to Insert and say Insert Mesh. And then you can bring in an STL file. Versus going over here and go into a project and say Upload. And the reason for that is that when you do upload, and I'm not, so maybe I should have taken it a little bit deeper, but when you do it through the upload buttons here, there sometimes can be a translation error where it scales up. So the recommended way is Insert Mesh. So I'm going to insert this type of mold cavity here. And you can see when I click to insert it, I kind of like actually get some units up here. We can flip that around. We can move things around. I'm just going to say okay to this for 1 second. So here we have an STL file. We're going to come back and talk a little bit more about STL files a little bit later. This is kind of like a mold of a toothpaste thing, and I'm going to talk a little bit about that a little bit later. We're going to come back to that because the title, and I want to show that we can absolutely machine a STL file, or what we call this a mesh file. You would actually see we get an icon down here, and also if we open up the bodies folder, it's a mesh body. The way to machine this is to go to CAM. That's maybe obvious. And of course, we're going to create a setup. Now, here's the most important thing. And when people have reached out to me, they couldn't get this to work. The biggest, thing that people miss, and I don't blame anybody for this, you have to go down here to the model area, click on that to make it blue. Then you got to select your STL file, your mesh file. So in the setup, you got to go and select it. The reason for that is by default, Fusion is looking for a body or component, right? So if you don't select something, it doesn't know, it doesn't see anything. So make sure you click down here and click on the mesh so you can see that that's the mesh file there. So that is one thing that is important. Now another thing you will find in here when I go to change my origin, so we're always trying, at least if you're doing like a vertical machine, we want the blue to point up. That and I always say you got to use the Z-axis plane. That you actually can't select on the mesh, right? Because mesh is a weird thing. It's not a solid or a surface. So here you will have to use one of the three planes, but that's fine. So click on this and hit OK, and you're kind of like where we normally will do when we are machining. Now, the next catch when you're using an STL model, and we're going to come back, I'm going to show you some other tricks here. But the next catch is that none of the 2D tools works in a mesh environment. And again, the reason for that is that all the 2D tools are looking for some sort of solid or sketch geometry. Now I'm going to show you the workaround just in a second, but that's important to know that if you ever got a machine and an STL file, then you cannot use any of the 2D. You have to use the 3D, but it's okay. So the way I set this up with this setup, I just went default, right? I didn't go in and change our stock or anything. So we actually have a little bit of stock on top of this STL file. If I go back into the setup and we go to stock, I never touched that, but you can see by default it added a 1mm on the top. And many times when we're doing CAM, the first thing you always want to do is kind of like face off the top. But we can't face off the top right now because we don't have any solid to face off. Now, you can use, in the 3D environment, use the horizontal for that. So if I click on horizontal, then we get the normal menu. I'm going to hit select for a tool. So it's the first thing we select, right? And I'm going to, just like I always try to do, I'm going to go down and select the tutorial metric catalog that comes with Fusion. Select the 16mm, so you all have this one. Hit OK, and just hit OK to that. I always say that whenever we are doing 3D toolpath, the best, I don't know if it's the best, I shouldn't say the best. My rule of thumb, because what the heck do I know? My rule of thumb is whenever you're doing a 3D toolpath, select your tool, hit OK, see what the software gets you. So you will see we get something here that could resemble a facing operation. Now, it's not necessarily perfect per se, but it will definitely, face off most of the part here. The only section actually that this will leave out is the center portion. I don't know how good this is to see. The center portion here has a little bit of step up, but that's fine, because the next thing we will do after facing our part off is roughing out the material in here. So to rough out that material, I would use a adaptive. We've talked about the adaptive before. If this adaptive is brand new to you, maybe a little bit scary, send me an email. I think I have a good live stream that kind of like digs into that. Again, select the tool. I'm just going to leave the tool, the same 16mm tool. So since I've selected my tool, I'm going to hit OK and just see what the software gives me before I go in and start doing any changes. And this is awesome, right? Because it's roughing out all the stuff here. And it actually also sees that there's stuff on the outside that it wants to rough out too. Now, if we didn't want it to do that, if we didn't want to rough out the outside, just a quick trick. If we go back into adaptive, so right click on the tool operation, hit edit. If you go into the geometry tab, you will see that right now it's set to none, but it means that Fusion is just going to machine everything that it sees. You could pick a silhouette toolpath. Silhouette, and then if you set tool inside boundary and hit OK, then you will see it's not doing the outside. So what does that mean, silhouette? Think of silhouette in the selection as almost like shining a lamp down from the top. Anything the lamp kind of like hits something on, that would be a silhouette. So machine everything is kind of like C. But since we put the tool to be inside that boundary, it will never work on its way out. So here we got a nice little roughing toolpath here. So if we simulate this, we will first have the facing operation. That's fine. We can fast forward. Let's get the 3D adaptive here. It's going to rough out. And the 3D adaptive is actually it's a 2D toolpath in the manner that it goes down in steps versus doing three axis movement. But it's a really, really nice toolpath. I was talking about the other day how you can use CAM to make cool texture on a 3D printed part, and this actually, I think this looks very much pretty cool with these steps down. I'm always thinking like, the Grand Canyon. If you applied the adaptive toolpath to an STL file of the Grand Canyon, it probably looks pretty cool because it has these steps down. So we roughed this part down. So as you can see, this is kind of the steps you would go through to machine an STL file. It's just this mesh file here. Now, where we start running into some challenges, so after I machined, so we finished the top, we roughed out the center. Now we're kind of ready to start doing the inside here. Where we start running into some issues is with some of the selection areas, because when I'm looking at what is the next toolpath after the roughing it out, I would probably, and I'm going to come back to this in a little bit later, but I would probably select a parallel cut. That is kind of like, I call this an old mold maker toolpath. I think that this is just always my go-to, either as a semi-finish and many times as a finish. Now I'm going to use this as kind of like a semi-finish. So I'm going to select the parallel cut. I'm going to select the tool. Now we're going to switch over to a ball end mill, because this is what we normally use when we get into this. And in the tutorial for metric tutorial, you'll find a 6mm ball, but actually fits pretty well. I think you guys kind of like start roughing some material out. Now, like I said before, anytime I do a 3D toolpath, I select the operation, I select the tool, then I hit OK to see what we get. And this here looks it looks like it's giving us something, but I really don't want to machine the outside of this. I really only want to machine this inside here. And that's where we start hitting a little bit of an issue from here. Now, like Peter says, rest machining, and I'm going to do a separate one on that. You could try to go in and use a rest machining on this. I actually haven't tested this out from previous operation. I'm not sure what it's going to do here. And that would kind of like give us something that we could work on, but it's probably not really exactly what we want. We're now starting to fumbling around. The problem is, again, we're using an STL file. We're using a mesh that doesn't have any lines and arcs. So lesson number one out of this is, yes, you can absolutely machine an STL file within Fusion. That's what we're doing here. But you need to understand that there is a little bit of limitations with that, because we don't have, faces, lines, and arcs. And that brings me to, let me now show you what I really would do. And I'm saying that with this model, because I think it's important. We talked previously in the week, and I know some people maybe didn't catch that. We talked about this whole thing about facet counts inside of STL files. So STL files is just made out of triangles. Just remember that. And many times we don't have a good control over these triangles, the accuracy of that. And let me just show you what I'm talking about. So what I did, I'm going to open up a new file. The way I created that mold that you just saw, the toothpaste, was I was actually trying to be a little bit creative. And I always look for things to kind of like use in these live streams. I was standing this morning brushing my teeth, and I modeled up something, I don't know, quick, that was supposed to resemble my toothpaste. Now, you inside of Fusion, and I think actually I'm probably going to model this one up on Wednesday evening on Facebook. But you can save out as an STL file. And when you do that, so I right-clicked up here. I know this is CAM. We're going to go back to that. I right-click up here and say save out an STL file. When I do that, right-click, save as STL file, you get an option of doing different levels of accuracy of this of an STL file. So let me show you what that really means. So if I go up here and I say insert mesh, I kind of saved out 2 versions of this. So there's one I called toothpaste low. So I saved out the STL file with a low mesh count versus, let's open up another file, insert mesh, high density. So if you look, especially on the side body here, this is the high one. Now look at the low one. You can see how there's a lot fewer triangles on the low output versus the high output. Actually, in Fusion, we can go to the low output. We can right-click on the mesh body and say properties, and we can see that this one is made out of 1,730 facets or triangles or faces, whatever you want to call it, versus our high end. So that was 1,700 something. And this one is 11,200. So I mean, you talk, one is 11,000, one is 1,700. So so the reason that is important, and the reason I wanted to bring that up in this live stream, is because the more triangles you get, in theory, the more accurate your model is, right? Like if you have the one with a low facet count, anything that has like a curve to it, if there's only 3 triangles, that's not a curve anymore. That's 3 flat areas put together. So the problem when it comes to machining STL files in any CAM software is that many times you don't have control over those triangles, and those triangles will, of course, also be resembled in when you're machining it, because the CAM software is just machining what is there, kind of, right? So I wanted to make sure that I showed this so you have an understanding that whenever you're bringing in an STL file and you start applying different toolpath to it, that these triangles is a little bit of a nightmare. And one person left a comment yesterday that was like, "This is stupid." Well, that was not what he said, but kind of like the intention of the comment was, why can't we just make it better? The problem is that these STL files you're looking at this is what there is. There's just triangles resembling the original shape. You're seeing here the original model that I modeled up inside of Fusion. It is lofted, it's revolved, this is smooth. But as soon as you export it out in STL, then all that gets converted into this. So I hope that kind of makes sense. Now, so what would I do if I received that mold that we just looked at as an STL file? So this is where we're going to get a little bit further into the CAM and hopefully show you some tricks if you're getting bored out of your mind. So I'm kind of like starting in the same place we were before. I'm bringing the STL file in to Fusion. And so right now, if we look at this one, the first thing we probably should do is going in and see how many facets does this one have. So this one has 5,600, but it's actually not that necessarily many facets. Anything under 10,000 is a pretty manageable account of facets, and you can actually very easily convert that. I have made other live streams that if you have a really high facet count, what you can do then. So send me an email if you can't find them, or go and look for them, whatever. My email address, lars.christensen@autodesk.com. So what I would do with this, if I got this, instead of jumping right into CAM, I would actually do something that I very, very rarely do, is that I would go in and right click up here and turn off capture the design history. And it's going to give you a warning about that. Because when I turn that history off, now we're in what we call direct editing mode. And I've done live streams on that too. But look at this. I can now do what I did the other day. I can right click and I can say convert the mask to a B-wrap, what will turn it into a solid model. Now, when I do this, there is going to be a little bit of conversion going on in there, but generally I'm keeping the same mesh as I had before. But if the model is watertight, I can actually get a solid body out of it. So that's what this is. This is a solid of this. What is awesome. This is something we can now start working with. Of course, it's still a solid built out of our STL file, so we still have all these facets in here. So that's important to know. But this is something we can somewhat work with. So let's go back into CAM, because when I do this now, I do end up getting some of these functionalities that we normally like. First of all, I don't have to select the mesh file anymore because now I found the body. And when I go in and select my orientation with the Z-axis, I can just select one of these. Now these are kind of like broken faces, but they're flat. So I can now select those. I get the option to do all the things that we would with kind of like any solid. We could go out down here as a box point and select, the stock is where we want our pickup corner, all that stuff. So when I have this now, then I could, if I wanted to just do a standard facing operation, I could now absolutely go and select the standard facing operation and go through the steps of selecting, a face mill here. Go ahead and hit OK, and that will now work because it is now a solid. Now, like I said before, I would probably still use the same adaptive clearing as we did on the mesh file. That would actually not change. So we'll go in here, select the tool. I'm going to select that same 16mm flat end mill we called up before. We already made the change to say the machinery boundary. We maybe just want to do silhouette. We maybe just want to tell the tool to stay within that boundary. And that is going to kind of like rough out all the same stuff. Now, where this is nice versus our or our STL file, our mesh model, is that when I go in now to do the parallel cut, and let's select our 6mm ball end mill, right? Select that one. Before I selected that and I hit OK, I'm just going to do that again so we get the same result. We got all these cut across here. Well, now we can actually go in because there's something we can select. And I'm going to do, instead of silhouette, I'm going to do selection. I'm going to show you a really neat trick right now. So pay attention. No. So when I go in and hit the silhouette, I can actually select an area here, but notice because the model is kind of like broken up a little weird, when I select this upper edge, look at how it has a tendency to kind of jump around a little bit. I want to get the whole toothpaste area, and right now I'm missing a little bit in the upper left. It gotta be. I'm gonna select it anyways. Now if I go on the top, you can kind of see that I'm missing something. Then select that green again, and then you get this area here where you get a little dialog that comes up, and now you will see that and this is the CAM developers. I mean, God bless them. Right now you can kind of see the blue line and where it's kind of like trying to find a area. But as I'm hovering over other edges, it will try to calculate to that. So if I select down to the edge here and click on that instead, then it will actually try to see if it can convert into that area with kind of like this shape. Now it looks like that this one really went haywire on me. So this might be a little bit of a challenge. Let me try. You gotta kind of find where. Let me just try that again. So here's the green one. Select that again right there. And you can see how it's kind of like trying to follow that. So if I select up here, I should be able to get the area right around there. Let me hit the green check mark. And I'm actually ending up getting 2 green. This is actually not what I want. Ha! This is the wonderful thing about doing... Well, this is actually... well, this is what I want. This is the great thing about doing live streams. I want that whole area. Well, so now be aware of that if it misselect, you can actually go in and start... If you click on the same, even this is the wrong one, I got the right one, but now you can see how it's trying to find out with all the edges what it wants. So that's what I want. But I want to select this area here to be my toolpath within. I hope that didn't become too confusing. So now when I hit OK, you will see that the toolpath just stays within that area. I would actually machine the other direction with a parallel. So kind of like going against the grain. And I think that may become, so I'm going to change this to 90 degrees. I think that comes from being a mold maker and you want to polish things up. So you got to go in there with a stone afterwards. The step over here is way big. This is a roughing. And again, I've talked about this in other live streams, the step over. We can definitely revisit that. This is a roughing. I'm going to minimum do it at 0.75 millimeters, I think. Hit OK. And you can see that probably does a pretty nice, in this area, it does a really nice job cleaning it out. We're missing a little bit up here, I think. Let's go in and simulate this whole thing. I hope this is useful. Let's go to the parallel. So here we kind of had our roughing operation. And then we start the parallel here. It's kind of like just going back and forth, back and forth, back and forth. Going back and forth, kind of like even this area out here. If you don't want to see it going all the way to the end. And by the way, I'll make this model available. Email me and I'll send you the model if you want to take a look at it. You can also just click here to go to the end of it. So then it will just recalculate it. Go to the end. Now this one is a little hard to see because this mesh environment is kind of behind it. So it can be either, if you go up here, we can actually turn the mesh off. Now we only see the machine stock. And this is super helpful because this is actually kind of like what it would look like in the real world. Now remember, we're pretty close to this right now, but you will see that the steps here are a little rough. Now again, I have tried many times where people have been, or I have been looking at things like, ooh, that looks pretty bad, but in reality, you're like holding it right in front of your eye, right? So this is a pretty good, I think, roughing toolpath, but I would probably go and try maybe the scallop as a finishing toolpath. So let's go with a little bit smaller end mill for the finishing toolpath. So let's hit select to get another cutter. And I know in the tutorial metric 1, you will find, let's take a 3, that's half the size. Again, we can talk cutters and all kind of other things. As normal, I would just hit OK and see what we kind of get. That's kind of like my rule, and it's kind of hard to see, but you can see here it's machined the whole outside. So we want to do what we did before, going in and use a selection to kind of like narrow that down. And now I know I can select that back edge and it is all perfect. Lucky me. This step over here, again, is very high. I would normally, I think I would start out with a 0.5 millimeter and then work my way down from that. That have normally been my, like in steel, I guess, have been kind of like my standard kind of step through. And if we go in and simulate this, it's probably a little bit easier to see. Go and simulate it. Let's just go all the way to the end. Let's turn the body off so we can see the end of it here. You can see how the red bar down here that is still calculating if we're looking at the bottom of the screen. It's almost there. And you will see now that we got a lot better kind of like area in here. Again, I'm very close, but this looks pretty good. We kind of got, you know, a little bit of a roughing area, a pattern down here for finishing this up. But this would probably be my start out if I was just going to throw some tool. If you threw this on me here and say, hey, machine this, that's probably what I would throw on and be like, this is a good place to kind of start. Ha! Man, I did this in exactly 30 minutes for a Friday. Whew. I'm getting in the rhythm of the length of live streams. That is awesome. I hope this was super useful. I hope it was not a waste of your time, of course. Like I said, I normally try to do a good job of saving these models. I'll share them with you if you wanna take a look at them yourself. I hope that you found a couple of neat tricks out of this, how to approach some of this stuff if you gotta do some of this 3D machining. What else do I have to say? Monday, I'm off Monday. It's holiday here in the United States, and I am going to take advantage of that. So I will be planning on being back on Tuesday. Again, thank you so much for all you guys who take the time to do a thumbs up or a thumbs down if you don't like it, and you know your comments is really always appreciated, and your suggestions for new topics and stuff like that. You guys are awesome. I hope you have an awesome weekend planned. Do some relaxing, maybe have a cold one. You probably deserve it. And I'm going to do what I normally do, end the broadcast. So if you're watching the recording, thank you so much. If you're in the live stream, I'm going to jump in there and say hi to everybody. Until Tuesday, guys, I hope you have an awesome, awesome weekend. Thank you so much.